and they want to talk to you guys about it and see if there was any interest in it. So the general gist of what's the ACM programming competition is about is anyone is welcome to join, and you're going to work in teams of 3 or less to compete. It's completely online and it's completely free. And anyone can do it, from a freshman to a master's student. So, if you want to do it, if you're interested, please sign up. And I will put some links in chat a little bit about this. So the North America qualifier is Thursday, February 11th. It's a 3-hour event. But you're not required to participate in it if you want to do the actual competition itself. But if you want to do it, go ahead and do it. And then there's a link to register. So the NCNA, which is the North America competition that we're talking about here, is going to be February 27th. It's open for registration right now. So we have teams of 3. So if you get a team together, just send Austin O'Brien an email saying who the team participants are, your team name, and shirt sizes, and I will send his email in chat. And you need to do this by January 22nd in order to receive a T-shirt for saying that you did the competition. You can still register later, but you're not guaranteed to get your shirts by the competition date. And 150 teams from the regional February 27th will be invited to compete in the championship, which is NADC. And if you look at it, that's pretty good odds for multiple DSU teams making it through to the championship. And it would be really great to see DSU do really well. There are some practice competitions going on every Saturday until then, so until that February 27th deadline. And I have a link to register for those practice sessions. So if you have any questions about this competition, email Austin O'Brien or talk to any of the programming club officers. I'm sure they'll go a little bit more in depth on Thursday. I believe is their next. They're going to meet this Thursday for programming club. If not, it'll be the week after. So yeah, but I know it's a lot of information, so I will link kind of the bullet points in chat in a second with the links, so you guys can check it out on your time. And if you're interested, please do participate, because seeing DSU representation on a national level and going up against other schools, it's a really great experience and looks great on resumes. And other thing I wanted to add before we get started, and I let Jake take it away, is we're not going to meet next Monday because we're actually off. Like the 18th is a day off for school, so we figured we'd let you guys enjoy your 3-day weekend. So yeah, there's going to be this meeting tonight, and then our next meeting will be 25th of January. So yeah, I'll let Jake take it from here.
All right, thanks, Ryan. Well, everyone, welcome back to Computer Club. Hope everyone had a good break, is ready to kick off another good semester. Be sure to fill out attendance if you haven't already. Then we'll go ahead and get started. So today we're going to be talking about debuggers, but we'll be specifically working with GDB. For those of you who have not worked with a debugger before, a debugger is a software that we can use to interact with and step through a program as it's executing. This allows us to take a deeper look at the execution flow of our programs and makes the process of debugging easier, hence the word. If you've ever manually debugged your program by adding 20 print statements, this is a much quicker and easier alternative to doing that. So it makes bug hunting a lot easier as well, because you can go to the exact line in your code that it's breaking and see it execute from there. So there's a lot of debuggers out there, better than GDB probably. I think VS Code and really any other text editor you can use has one built in with probably better UI too. But the fundamentals of most debuggers are fairly identical, so the knowledge learned here today from using GDB should translate pretty well anywhere else. And plus, on most of the servers you'll use in programming classes, like your 150, 250, 300, they should have GDB built in to the server. So makes it easy to debug your programs right there. So now to actually how to use GDB, it's pretty straightforward. All you need to do is just add a TACG flag when compiling your program. Then from there, you just launch the executable with the GDB command in front, and then you're in. So the first kind of fundamental thing we'll learn about with GDB is breakpoints. So when you run your program with GDB, generally it'll go to the end of the program unless you have what's called a breakpoint. That tells it where to stop execution. Most of the time, you'll want to break on main to start. So real quick, I'm going to do just a quick example just to show what it looks like. So I have a dummy program right here. One. So this one's just a bunch of empty space. Basically, I just did a bunch of print statements. But like I said, again, to compile it, we're going to do gcc tacg, name of the program, program1.c, and then gdb a.out, the name of our executable. So from there, this is the GDB interface. Like I said, we're going to try to add a breakpoint on main. Actually, if you just run the program from GDB like this, you type R to run, it'll basically just run like you would normally do it at the command line. So that's why we need breakpoints. So if I do a breakpoint at main, and then we type run, you'll see it'll stop here at line 4 in main. That's where we set the breakpoint. So that tells it where to stop. If we wanted to set another breakpoint, like say we can break on functions and lines of programs. So we wanted to break before line 12 here. I just type br12, breaks there. And then another new command we use will be C. That'll continue to the next breakpoint. So it goes to this line 12, which is of. Pretty simple there. And then can kind of just go to the end. Oh, I forgot to mention, N is just go line by line. I'll just restart the program again. And N goes line by line through the program if you want to do that, instead of using just a bunch of breakpoints. If you want to delete breakpoints, you can type info br. This will list, as you can see, this will list the 2 breakpoints I set, the one on line 4, beginning of main, and the one on line 12 with this print statement. So that's kind of just the basics of using GDB. Getting into it and jumping around. We'll do more better stuff in a bit here. All right, so that's breakpoints. Controller execution, I just did that one, or did a few commands from there. So the things you just need to remember is R is run the program, B breaks it, sets a breakpoint, N goes to the next line, C continues to the next breakpoint. There's a bunch of commands in GDB actually, and there's a list I made right here, or not, I didn't make it. There's a link to a bunch of commands that you can find for reference. So stepping is another important thing. So whenever we encounter a function, you can choose to either just kind of go over it, or you can step inside of it and see the commands as they're, not the commands, the code as it's executing in the function. So I'll put this second example here. So this one's again pretty simple. It's just in main we just call this add function, which just adds 2 numbers, returns the sum. So I'll compile it with GDB, the tacg commit flag 2. So this time we'll break on main again. We'll run until we get to main. Go next. And you see we get to this line right here, which has our function call right there. Forgot to mention too, if you want to see all the lines within this GDB view of your code, you can type list. That'll list most of them. You can type a number. List 15. That'll list up into 15. But anyways, to step inside this function call to add, we just type S. and then it'll do these lines here inside the function. Sum is num1 plus num2, return sum. If we hadn't done that, if we hadn't done the step, and we just did another n to go to the next line, it would have done that function call. Basically, it would have just skipped over it, still executed, but we don't see what's going on step by step like we normally do. So that's stepping. Next thing. So basically, all we've done so far is taken like a slow motion look at it so far. There's other more useful things we can do in GDB now. We can print, set, and watch variables. So print will, it's pretty self-explanatory. It'll just print the value the variable holds. Set, we can actually change the value a variable holds to kind of go down different execution paths in our program. And watch will pause, or it'll go until it sees a change in the variable we specify, which is actually kind of useful for some debugging applications. So I have a program where I'll just kind of show that usage off a little bit here. 3. All right, I'll go over this one real quick. So basically what we're doing here, we're generating a random number between 1 and 10,000. Ask the user to guess that number. If the number they enter is equal to the random number, they get this winner function called, does a bunch of stuff. Otherwise, they lose. It prints this statement that says so. So what we'll experiment here with a little bit is just kind of seeing how the variables change and how we can actually change the variables to kind of jump around through these if-else statements into the function and kind of manipulate some stuff. So again, GC syntax G, 3, B, dot. So I'll break on main again. Kind of, we'll just step through kind of line by line. Got to run. Through generate a random number. And then here we'll enter a number, say 22. Then I guarantee I probably won't guess it, right? Yeah. So this time when we run it, I'm going to step through and actually, there's 2 things I can do to kind of manipulate this. Let's see what the random number generated is. Something we could do. Lottery num. So we can use that print statement I went over before and the variable name. And that'll print the random number that it generated. So then we can go from there and we'll be like, oh, we know exactly what to type here. So we can 8743. And then this if statement will now evaluate to true, which is useful, so we can kind of go through there and hey, we got the flag. So yeah, it's useful doing the set or the looking at your variables is useful. Like I said before, when you're usually manually debugging, you'd probably, and you wanted to see what this random number generated, maybe to make sure it was in the right range or something, you'd probably like enter this printf statement to do it manually, and that'd be kind of painful. But with GDB, we can just kind of print out the information we need. Another way we can kind of tinker with the execution flow here is that set command I showed you. We can set actually the variable to completely another value, so we could just make it 5 or equal 5. And then the number we enter, we can make it 5, and then both will value to true. And then we get that function to call. So that's kind of playing with variables, looking at them and changing them if we want to. Oh, and then one more, watch. Let me look at this again. So sometimes if you have maybe a long branch of if-else statements you're trying to get to, we can do this. Or wait, no, I'm thinking of the wrong thing. We can use watch to see when a variable changes. So say we wanted to pinpoint the exact location the lottery number is generated. We can do watch lottery num. And then we can do that continue again. And it'll jump to just the point where that lottery, just after that lottery number is changed. So that's kind of, again, useful for just finding stuff that's wrong with our program. So here's condition. So we went over just normal breakpoints. We can also do conditional breakpoints. So again, we can say we only want to break the program, get a breakpoint if the user num and lottery num match. So we write it like that. There's two variable names. So that sets another breakpoint for us, and so that way, if we do want to continue and we don't want to bother like going through this line by line and just get to this else statement, and only this else statement, we can just continue, enter a number, and then we just kind of go through. It would have stopped if we got to this, because if the only thing we really want to see here is this winner function being called. So it would have stopped if that condition was met, like we showed before. So arrays, most of the stuff in GDB you'll find is like really similar to referencing stuff you would in a normal program. So arrays aren't much different than just referencing normal variables and arrays. So all right, here's the next file or program I'm going to be working with is we're going to generate 10 random numbers, put them in an array, print out the contents of the array, and then we'll do something with this later, but we'll just work with this for right now. So finally run this one. Break on main again, and then run. So we'll just go through line by line here. We initialize our array. And then another useful trick here is you'll see we're going through this entire for loop. Every time we get to the top, or each iteration of the for loop, it just starts over again here, and it just prints a ton of times. If you don't want to see if you have a really long for loop and you don't want to see the entire execution of it, you can, what you can do is set a breakpoint after the line after the for loop. So I could break on 17, which is just this print blue line, and then just do a continue from there. And then we're out of the for loop. So now looking at our arrays, we can, just like with variables, we can just do a print. Our array is called ARR, and then pick an index, 5. That'll print 43, which is one of the random numbers generated there. We can print the entire array if we just go print array. There's the entire list. And then this one I wanted to show actually has an error in it. So the second part of the program is trying to find the max number in the list. Pretty basic, but like I said, there is a problem. So I'm going to kind of show how you can use GDB to evaluate and find problems. So if we just run this, just outside of GDB, take that out. You'll see that this finding the largest number utility just doesn't work at all, because that is not in our list and that is way too high of a number. So we'll kind of dig in with GDB and try to find out what it is. Read that out, break main. So actually, I'm going to delete that breakpoint. Usually if you can kind of pinpoint where the problem might be, you can just break there. So I'll break on the 22. And then it's the best way to do this. So I think the best way to do this with what we've learned and using kind of some GDB stuff is we can set a watch for whenever the max changes. So then we can see when exactly that large number gets put in and why that's happening. So we'll watch max, see whenever that changes. I need it on the program. All right, so we'll continue. So we see it. This is normal behavior. It's just finding a bigger number, going. So it doesn't break every time. I have to run it one more time real quick. Next, continue. One more time. Sometimes I think it generates a negative number, which is why that's happening. All right, there we go. So we see this, the old value is 79, new value is this large number. So this is where the problem's occurring. So we can find out where exactly that is in this for loop that's happening by just printing our index value, which is I. So just print I. And we see that it's 10. So we kind of have a little off by 1 error. So it's trying to print an array location that's out of bounds. So that's why that's happening. So we can just fix this by getting rid of this less than or equal to. And that's some basic debugging with GDB. What else do we got? You can also run with arguments in GDB. It's pretty simple to just do 1 or 2 if there was arguments in this program. You can also run with an input file by just doing a little arrow like that, and then the name of your file that you want to run, use the input from, just like that. And I think that's all I got. Any questions? Or anyone want me to review any specific?
I have a question.
Yep.
How do you attach GDB to a running process?
Running process?
Can you do that?
I don't know how. Does anyone else? Anyone in chat?
Try GDB-P.
GDB-P.
Try that.
Got help from our studio audience. That's how you do that. Any other questions? All right. That's all we got for tonight. Thanks for coming, guys.
Thanks.
Woo! Sign up for the programming club competition if you're interested. It'll be fun. Good experience for everybody.